Welcome back to Coding Game, the Summer Challenge 2024. And we're continuing with this Olympic thing. It's going to take me a while to get all 4 games programmed. So I worked out the some of the maths behind how you predict the probability of beating someone if you are a certain amount, let's say X from the finish line, and they're Y from the finish line, and you're moving a random amount each time. Basically, it comes down to using I can't remember the terms. Well, if you find the CDF distribution of the time it takes for you to get to the finish line, then you apply the central limit theorem. So basically just pretend it's a normal distribution. Then it comes down to working out, it's basically this. You want norm, well, what's the Python? Okay, well, it's like, normally you write it theta of, so it'd be if I'm at position Y, no, if I'm Y, let's write this out. Root Y beats Z. And then that is equal to theta of Y minus Z over 2 root Y plus Z. Hello Nathan, welcome in. What's your question? Is it to do with coding game? That should be divided by 8. Y plus X, Y plus Z divided by 8. That is all within the square root. That's an estimate. That's what you do. You use the normal distribution to estimate things which are kind of like binomial distributions or Poisson distributions, which are too computationally expensive to compute over for large ranges of n. Oh, look, there I am. Again, I'm the only one streaming. Sure, Nathan, I'm curious to hear your question. So that is roughly Y plus Z, Y minus Z divided by 2 root Y plus Z over 8. If you could choose anyone to see get tickled as a prank, who would it be? I don't think that's a very funny prank. I don't know. It seems like something that you'd see in the 90s on those old prank shows, but I don't I don't know. It seems a bit dated now. So yeah, I mean, the answer is I wouldn't really. I don't really find that kind of thing funny. I mean, those prank shows where they do stuff like that are all scripted anyway. So like the people they do the pranks on are in on it. So once you know that, then they don't. That makes them even less funny. So the probability of y beats both x and z is, because these are independent distributions, it would be you multiply these two. You need y beats z and y beats x. So you just apply these distributions here. All right, so that I think that will give me a rough measure to describe how likely it is that I'll win a certain race. And that will help me decide whether it's worth investing more or not. But that only really applies for the first game, because the other games are not of the same form. I mean, archery. After 12 to 15 turns, so do you know ahead of time when the archery is going to end? I guess. Oh, you do. It's in the GPU. Okay. Hello, Amaro. So this one is similar, but it's not quite. It's not that you're trying to be the first to get to a goal. You're trying to be the closest to the bullseye. So the distribution will be similar to this, but not the same. I need to do the maths again. Okay, well, don't worry about that for now. And then the roller speed skating. Hello, Dahi Ninja. I'm messing around with normal distributions, Gaussian distributions. Roller speed skating is... When does it end? Oh, it's determined by the GPU. So that also is a fixed number of turns. But you win by being the furthest ahead in that fixed number of turns. Okay. Reg 6 is turns left for skate. Oh, okay. Oh, the GPU is just talking about this turn and... Oh, yeah, of course, it's this risk order thing. Okay, but okay, so Reg 6 tells you the turns left. Okay, so again, it's a fixed number of turns. Diving, what's this? Oh yeah, this is like the Dance Dance Revolution type thing. But again, this, yeah, it's a fixed length. All right, so the 2, 3, and 4 are fixed lengths, whereas 1 is sort of kind of like a random walk where you can move 1 space, 2 spaces, or 3 spaces, or be stunned, or 0 spaces. Okay, well, I think offline again, I'll have to think about the equivalent of what I've written here. But this roughly applies to the first game, I think. Where theta is just the Gaussian distribution. I suppose you say norm. No, you say theta because normally you write it like, that's the standard normal distribution, which is what I'm using here. Okay, so with this in mind, I can rewrite this measure here. So how did I do it before? So I said just what did I say? I think I assume they're moving 2 spaces each turn or something, and just count how many turns it would take to get to the goal. We can scrap that because it's just too basic. All right, so I think what I want is a method here. So if we know the hurdle state, oh, this is quite easy actually. Okay, so is that all? I thought I had more. Oh, I deleted them all. Okay, yeah, so this is literally all we have in the game class. My hurdle state. So what we need is enemy hurdle states. Is that? Do you write it like that? Or do you just write list? What? Oh, you do it with small l. Oh, yeah, okay. Okay, fine. No, can I still specify what's in the list? I don't think you do that. No, you don't, because I mean, you can have different types in a list. Okay, so, so the idea is, given that I have, oh, I didn't factor in stun timers. If we're stunned, it's moot. It's a moot point because you can't do anything. You literally just have to wait until you're unstunned. If the enemy is stunned, that means we have to add on hang on. So if they're stunned for 2 turns, Then we'd have to add 2 to the... No. Alright, we're just gonna have to ignore stunning for now. Because I can't think how that would change this formula. So I want to... So we've got my hurdle state, which is basically just saying this is my pause and this is my stun. And we've got the enemy hurdle states. There's going to be 2 of them in the order that we get them from the input, just to be consistent. And we want get, hang on. Get probability of gold for a given hurdle state. So the idea is we just need some basic measure of, like, you know, if we're so far ahead of them that there's a hopeless chance for them to catch up. So the chance is very low, like 1%. And when I say chance, I mean if everyone was just walking randomly picking up down left, right, and not being smart about it. So we're computing the probability that we will win gold given that I'm at this position and they're at this position, and everyone's picking random choices. And the point of this is that at some point it's either hopeless and we're never going to win, or it's a sure win. In both of those cases, we don't really care about this game, do we? So it will factor less because the probability is either going to be 0 or near 1. And if that's the case, then going up, left, down, or right lead to 4 different states, and if you plug in each of those 4 states into this, you'll still get roughly 0 or roughly 1. So the difference between the 4 choices is going to be negligible. That's the point of this. And you'll see a bigger increase from the other games, and therefore you'll choose the move which prioritizes the other games. That's the overall point, but it's going to take a long time before I get there because I've got to program the other 3 games. So get probability of gold for a given state is... How do you do normal distributions in... it's going to be from random import something. Python random normal distribution. I think Gaussian is the more common term. Oh, normal. It is actually called normal. Random.normal. Okay. Oh, this is NumPy, but we can use NumPy. But is there not just like native? Oh, you have to actually do it manually using the central limiter or whatever. Okay. We can use numpy. Okay. So probability of gold. So the positions, let's just say x equals total state dot pos. That's us. We're x. But what I don't want x. I want x to be the distance from the end of the racetrack. So x equals self dot total. This is a making this a global variable just for convenience. What did I call it? Total track. So that's how far we are, how many steps in units we are from the end. So we can say y equals, just say, so it'd be like this. So we want probability that x beats y and x beats z. Y and z are independent. So if we fix x, we want the probability that y loses to x, and we want the probability that z loses to x. And because of independence, we could just multiply them together. So need a helper method here. No, we don't. We can just have an all right, we'll make a method for this. Just call it define. What are these things called? CDFs? Cumulative distribution function? No, that's not what it's called. PDF, probability distribution function. I don't think that's even what it's called. I'm just going to call it P for now. P approx. Can't think of anything else. All right, P approx. So given I'm at X and they're at Y, we want probability player at X turns from finish beats player at Y. So that's just what was it? Random.normal. So we want X minus Y divided by 2 times dot square root. So it's going to be X plus Y over 8. Right, I don't even know if that maths is completely correct, but as long as it's some Gaussian distribution, that is with the right mean. So if X and Y, if we're both standing at the same place, X and Y will be equal. So this will be np.random.normal of 0, which is correct. So we get 0. We get 50%. Because the Gaussian of 0 is 50%. So as long as it's Gaussian in nature, that's still better than nothing. That means it'll still go down. It'll still go up as we increase X over Y, and it'll still go down as we decrease X over Y. Okay, so let's do that. I'm going to call this get expected medals, because we're going to return 2 values: the number of golds, the number of we should just say number of points. So you get 3 points for gold, 1 point for a silver, and 0 for a bronze. So the expected number of points will be probability of gold times 3 plus probability of silver times 1. Right? Are those the right numbers? I think that's what it was. Yeah. Get expected points. But this game alone. Okay. So we want probability of gold equals. So it's going to be we want X beats Y times X beats Z yeah, and then probability of bronze, because we don't need to bother computing silver if we've got both of these. It'll be, alternatively, we can just say like Y beats X and X beats Z plus the probability of Z beats X and X beats Y, but we could just do it this way. We can say bronze is the other way around. So y beats x and z beats x. Probability of silver equals, so it's going to be 1 minus okay, so the expected points are probability of gold times 3 plus probability of silver. That's it, right? Okay. So now let's try using this instead of whatever we had before. It's going to have the same result because it's the only game we're optimizing. So we're going to win that game and nothing else. But, so what we want to do is we want to say, so as before, so if there's no hurdle track, that means it's game over. So we say, so instead of saying scores, let's say points equals 0 for each direction. That's fine. So otherwise, so it's going to be get expected points of this state for each direction and state amongst the 4 different states. So best direction equals, so we want to max this time, not min. Max the points. Return best direction. So, oh, it's not taking the stun timer into account. Well, it's... No, that doesn't matter, because if we're stunned, it doesn't matter what we output. Well, more to the point, if we're stunned, then all the states will be the same. So all the scores will be the same. So this is working correctly. So ideally, this will just do the same thing as it did before. And we just win that race every time. Oh yeah, we need to populate the enemy states. So that's how we get my corridor state. So this is game 1. What? These naming... I'm not even using the right names here. That should be my hurdle state. There's none. Enemy hurdle states equals, I don't know, empty list. No, just make it none, because it's not even valid. There's no game. So otherwise, these are the positions. My pos is that. So then whatever's left. So that is enemy hurdle states. No, states. Enemy pauses. Pauses. Okay, that looks weird. Pos is that. My pause, we pop out the one that's ours. That leaves just the enemies. Stun array. This looks so ugly. Okay, let's just say enemy hurdle states equals this. Okay. Positions is that. Stuns is that. For I in range 3. If I equals player IDX, then we want to say that that is us. So do this. My hurdle state equals I stuns I. Or even better, just say state equals that. If it's ours, do that. Else dot append state. Okay, doesn't that look so much cleaner? All right, so yeah. All right. That doesn't look good. We're falling over. We're winning some of them. No, he's just running forward. He's jumping every turn. What? Okay. So, oh, whoa, look at that. We got a negative. Yeah, You can never get negative points. So... What? 11.78 points? Okay, something's very wrong here. So the normal distribution should always give a probability between 0 and 1. So regardless of what we do here, this should be between 0 and 1. This should be between 0 and 1. And this should be between 0 and 1 because these three should sum up to 1, you would hope. Of course, we're ignoring the possibility of getting ties because then that complicates things. Yeah, so, I mean, no matter what I type in here, this should only ever give me a number between 0 and 1, right? And... hang on, have I read this correctly? I didn't even read what this says. Is this actually the... Oh! This is not the theta function. This is... When you do this, random.normal of this, you've created some sort of distribution object. Whoops. Yeah, that's not... We've used this completely wrong. So, once you've got that object, you want... What's the 1000? Size? Yeah, we're leaving that blank. Oh, ho, ho. I get it now. So what we should be doing is that creates distribution equals that. So we created a distribution, and we want to return this dot. What would you do now? Well, this is running simulation samples. I don't want to do this. Well, I just want the I don't know the terms because I've not done stats in a long time. Okay, standard normal is clearly what we want, but still this is... Oh, damn it. This just draws samples. That makes sense. That's actually what you would want it to do. It draws a random pick according to this normal distribution. No, what? Oh no, it's I want the inverse, don't I? How do I do that? I can't even put in words what it is I'm trying to do here. I don't know. When I was in school, we didn't use. We had to have a literal book which had just huge tables of the down the sides, the variance and the means or whatever, and then you had to look up the value of the normal distribution at that. It's the CDF is what we want. No, it's not the CDF. Let me just search for Python compute probability of normal distribution being less than some value k, I don't know. Probability of a point taking for, yeah. Yeah, this is what I want. Is that right? Maybe it's right. I don't know. There must be something simpler. Ah, starting Python 3. Yay! We don't have to use SIPI. This is what I want. From statistics. What the heck? Where did this module come from? Look at all this stuff. Okay. So this. So basically we want where is whatever I typed before? Okay, so we don't, it's just standard normal dot PDF. PDF is the probability density function. So it will return a probability of a certain value being anywhere from negative infinity to positive infinity. It's a cumulative range, but PDF is the term for what we want to do. Okay. And it's this. Is that it? There is a problem though. The problem is we're not taking stunning into account, so we need to say, oh, but this messes up my... Okay, so for right now we can put in a hack and say x equals... So like the average number of spaces you go is 2. It's like 1, 2, 2, 3. So let's say plus 2 times hurdle state dot stun. Just add it. Now that's not. You shouldn't do that. I can probably recalculate it next time properly, but whatever. Just add in. So we're saying if you're stunned for 1 turn, that means you're 2 spaces further away from the goal. Whereas in reality, you're not 2 spaces further away from the goal. You're 2 turns of 0 progress. I can't think how to factor that in right now. So let's say enemy hurdle state stop. So we're factoring in that stunning adds to that. All right, let's try now. Hello, Brad. Looks like all right, let's see. So at the very start, you would expect to go 2 spaces forward, which would equate to jumping or down. Up and down are equivalent in this. So but this is not what we see here. For some reason, we get better scores from going left and right. Left is the winner here. What would left mean? Wait, are we 2 spaces? Hang on, let me see this. Left would mean to go 1 space. We know that's wrong. Ah, wait, this is not, these are not the same. No, no, that's fine. So bigger values are bad. That means you're further from the goal. I used C++ for Wood 1 and created a class and a function to find the next hurdle and act accordingly. It helped me skip level bronze. Now I'm in silver. I'm unable to do well in silver. Do you think if I use your advices for bronze? I mean, if you're in silver, I guess you're already doing well because there is no gold league. This can help me for silver. Oh, this, what I'm doing now. No idea. I haven't actually submitted this. This rank is for my wood code. I've not actually. This, if I submit this now, I'll just get a terrible rank because it's not. I've not programmed the other 3 games. Still just have the hurdle, and it's failing to do even the hurdle game. I'm trying to do a sort of statistical approach here, which is if I can iron out the bugs, maybe it will yield something, but right now I can't say whether it's any help. Will you try silver in this live? If I get to silver, yeah. I mean, the last competition I got to gold, I think. But yeah, I streamed it all the way till gold. We've only got 7 days left. Because I was going to do a different coding stream as well. Why do all the big coding events happen at the same time? Last time it was Advent of Code and this simultaneously. Hello, Crazy. I hope I don't get the statistical approach here. What I do there is to not use the player position, but in how many moves they can complete the race. Yeah, so the reason I'm using the statistical approach is because no one's really going to use optimal moves for one game, because that will harm them in the other games. So I'm just kind of pretending everyone is choosing random moves. And this gives me... The point of this is just to give you a rough estimate of how well you're doing in a game. And the idea is, if I can say that if from now on everyone does random moves, and I have a probability of 80% of winning, then I'm already doing pretty well. That's the idea of this measure. It's not even 100% correct because I'm approximating using the Gaussian distribution. To actually get it completely correct, you would have to use Monte Carlo simulations, I suppose. But the point is just to give a rough measure, so that way, when you look at the 4 different key presses, for each, you can say, okay, if I press up, then what this is going to end up with an 85% winning in this game, 25% winning in this game, and so and so. Whereas if I press left, it's going to give me 86% in the first game, and let's say jumps to 90% in the second game. So if I look at that and I say, okay, well, even though it improved, pressing left or up, I can't remember what I said, even though the second button improved the first game by 1%, okay, my example, I screwed up my example, but the point is, bigger jumps in probability in one game would mean then that is the ideal key press to do for overall. It's kind of hard to explain because I've not even coded the other 3 games, and but I mean, the important thing about this, comparing to random moves, is also unfair. Well, there's no notion of fairness because you're giving a rough measure of how good you're doing. And the important thing about this measure is that if you and your opponent are both really far from the finish line, then even if you're a little bit ahead of them, the probability won't be that high. It'll be a little bit high, maybe like 55% or something. It won't be that high. Whereas if you're really close to the finish line and you're still that same amount ahead of your opponent, then the probability will be much higher. And this function does that. So even if this function is not even correct, as long as it fits that kind of pattern that being closer to the finish line means the gaps matter more, then that's good enough to say I choose this option over this option, even if the numbers are completely not even related to the actual probabilities. It's the point is that it's ranking one option better than the other. But we have yet to see if it actually works because it's still bugged. It's still telling me to run 1 space here when clearly we want to run 2. Yeah, so here I've done this formula, but even if I were to plug in anything, like even if I were to just well, no, this function does actually matter because we want x minus y. So if I am in the same place as my enemy, then we would expect this to be 0. And then we would get the PDF of 0, which is 50%. That's definitely correct. Like, if you are standing in the same place as your enemy, then it's 50% chance you'll win. Well, I'm ignoring ties. That complicates matters. I'm pretending you can't tie break, but in reality you can in this game, so that we're pretending you're not allowed to tie. So that satisfies that important axiom that if we're in the same place as our enemy, then we get 50% in this function. For only the hurdle path, what if you create a function to find the next hurdle based on your position, and what is in front of you in the path, and then if GPU is not game over, the stun is 0, find the hurdle in front of you, and then do left, right, down, or jump. Yeah, but this is like overfitting on the hurdle game. I'm trying to avoid... Right now, I mean, at some point I will have to think more about the hurdle game, but right now I'm trying to just not even try to win the hurdle game, but just describe a rough measure of how well I'm doing in each of the 4 games. But I mean, yeah, you could well do that. But you still need to evaluate how... Even when you find the optimal move, you have to evaluate how much worth it is to do that versus, just taking the loss and getting a win in a different game. So that's the tricky bit. Because it's for a single game, it's kind of almost trivial to win it for all 4 games. So I think the strategy for winning a game doesn't matter. What really matters is how you balance the 4 games. Like if you've won a bunch of games, but and it's down to the last game, and you've got no wins for, say, the diving game, then it's trivial to win the diving game. You just match the combo completely, and then you'll win. Well, you'll get gold. You might tie gold, but you'll still get gold, I think. If you tie, you still get the medals, so yeah. Why does the music keep stopping? Video pause. Continue. Yes, continue watching. Damn it, YouTube. So yeah, I guess offline I'm gonna have to go back to the drawing board with these other games and work out what the because if I'm doing the stats thing for this game, I have to do roughly the same approach for the other 3 games as well. That way it will be the same order of magnitude between the 4 games, and then it'll be fair between them. Because that way it's not unbalanced. You're getting the same measure, which is a probability that ranges from 0 to 1 between the 4 games, and that way you can actually add them up without it being unbalanced. So how do I fix this bug though? So this is saying, so right now it thinks that going left from the start is optimal. Then something is wrong here. Okay. So hang on, is this even the right way around? So, okay, so I'm saying probability X turns from finish beats the player at Y turns from the finish. Well, this is the wrong way around, I think. So it's, your probability will be higher if X is smaller than Y. But what we're doing here, but if X is smaller than Y, this would be negative. So you get the PDF of a negative number, which will be strictly less than 50%. So is it just this? Swap these around. Try again. Still falling. Let me see if the numbers make sense. No, we get the same numbers. Come on, why would we get the same numbers? I just switched this around. It should be... Yeah, it should be completely different values now. What? Normal distribution.pdf. Right, well, I'm gonna have to add more logging here, but right, log, probability gold, probability silver, probability bronze for a given total state.pos. Wait, let's put the stun in there as well, just in case. It's got no stunning, except here. We've got 2 stun. Why is the probability of gold so high when we're stunned 2 turns? That can't be right. We're stunned for 2 turns. That loses so much progress. How can the... Why... Um, let's put x. X is number of spaces from the end. What? So this is, if we're 28 spaces from the end, this is our probability of gold. If we're 29 spaces of the end, it's higher. And if it's 31 spaces from the end, it's higher than 28, but less than 29? What? This doesn't even make sense. It's horribly, horribly wrong. Y and Z are fixed values. And they're not being changed, so they are the same in each case. So when X is bigger, and that's going to be negative, a smaller number. Well, this affects it as well, but... Alright, tell you what, let's just take this out for now. Let's do that. Y minus X. That should hopefully give us the right distribution. It's just not really in line with the actual probabilities, but... No, what? We've got high probability for 31, and a high for 29, and low for 28, and low for 28. And why are 29 and 31 the same? How is this even possible? I did not watch your last live for bronze yet, and I missed the start of this one. Can you tell me briefly what strategy you are trying to implement for bronze, please? Overall, I don't really know, but I mean, across the 4 games. Right now, I'm just focusing on getting some rough measure for the hurdle game of how good a certain state is. So if I'm at a certain position with a certain amount of stun, I want some measure of goodness, and a higher value means a value closer to 1 means it's really, really good. 1 would be perfect. 0 would be a loss, like a guaranteed loss, and just I want the distribution to be roughly in line with what you would expect for that. Once I have that, then I can just do the same for each game and then kind of combine them to get a rough estimate of, if I do up, left, down, or right, I want to see what goodness measure I'll get for each of those 4 games in each case, and just pick the one which gets me the best overall score. And that really all comes down to how good this goodness measure is. And right now I'm just trying to implement what I thought was a really simple one for the hurdle game, but it's just I don't know what's going on. I've made a mess of this. Maybe this is not doing what I'm expecting it to do. PDF. No, that's correct. So it should be the same every time. Oh. Wait, no, this is... Oh. I think this is the one I want. CDF. Probability of X less than or equal to... Yes, this is the one. But what does this mean? PDF. PDF should be... This is going to be 0. But it's not 0. But it should be 0. Because probability in a continuous function at any given point should be 0. Because it's a 0 measure. I don't know. I think we were supposed to use CDF. Let's try again. Yeah, because those numbers didn't make any sense. Oh! Look at that! Oh, he fell over at the end. But he is actually winning, at least. Why is he falling over, though? Okay, better. Oh, I see. Towards the end, it's guaranteed gold, so it doesn't matter what he does. That's correct. If it's worked out that it's actually physically impossible for them to overtake me, no matter what happens, then it doesn't matter what you do. And that's why he's crashing towards the end. That's actually correct behavior. So it's about here. They've decided here we've won and they can't catch up. Is that actually true? Because even if we were to stun on that and go like 1 space every turn, they are stunned right now. So when they unstun, it's there. That could be true. I can't be bothered to work it out. But okay, that function is actually working now. So it's CDF. Ooh. Oh, I read this wrong. Likelihood that a random sample X will be near the given value X. What does that mean? Near? How near? I don't understand. My understanding of the normal distribution is that should return 0. The chance of a normal instance being 98 is 0 because there's an infinite number of numbers it could be. The chance of any one of them individually is 0. So shouldn't it be 0? I don't get this. Fortunately, we don't have to worry about this because this is the one I should have been using. This is the chance that the instance will be less than or equal to this number. And that is non-zero because that makes sense. This one I don't get. I thought PDF is 0 at any individual point, and to get any meaning out of it, you need to take the integral between a point x and a point y. And that is how you get the CDF in the first place. Right, well, anyway, we got somewhere. So now we have a measure for the first game. Wonderful. We only have 3 more games to program. So not only is this giving a measure of goodness, but it's actually predicting how many medal points we'll get for this game. And you can extend that further and predict how many medal points you'll get for the entire game, not just this one game. Because this one game, let's say, if we just assume we get silver for all the remaining games, then actually no, it doesn't matter. It doesn't matter what we get in later games. Well, it does kind of, because if we know that there aren't games coming up, then it's safe to lose this game. So it's okay to get bronze, because we can just guess that we'll get silver in the remaining games, so we'll still get some points in this game. But if it's towards the end of the series, and it's like the final game, and we've not got any medals in this game, and we're looking at potentially getting a bronze, there's no more games after this. So we know that our final score is 0 across all games. And that matters more because that means we must do something right now and try and win this game. Screw the other games. Try and win this game and get at least a silver. So we do actually care about the whole series of games, not just this one game. Well, that's easy enough to code. You can just predict silver for all remaining games. That's just the easiest way to get around it, because that's like the average. It's not the average. The average number of points would be 3 plus 1, 4 divided by 3. So like 1 1/3. Yeah, so we don't predict silver for each remaining game. We predict 1.33 points for each remaining game. Do they tell us? Do they tell us which game we're on? No, they don't. So we have to work it out. So whenever we see a GPU, whenever we see a game over, how many games do you do? How many games do you do? Where does it say? 100. Oh, it just keeps going. It's not a fixed number of games. It just keeps resetting until 100 individual turns have taken place. Huh. Okay. And we'll know what the turn count is from this while loop here, we can say. Save, just count upwards. The rules are not going to change in silver, are they? They don't. No, they never do that. They always keep the same rules from bronze. So, So... So I think actually this method here, get expected points, we kind of want to do it for the whole game. We can adjust that. So we could say, well, we need a new variable. We need turn count. So this will actually be for turn count in count. We want count. No, what is it? ITA tools. Nope. I thought it was ITA tools. That was a small c. So here we plug in turn count. And we say, okay, so here we think expected points this game equals that okay, this is quite important. When the first two players win, does the game keep going until the third player gets across the finish line? No, it finishes. It finishes the moment. Oh, this changes things now. I'm gonna have to rework this because if someone is close to the end, then the game is about to finish. But the way I've coded it is when if I'm in second place and I'm just in front of someone in third place, but the winner is way ahead, the way I've coded it is the probability that I beat third place is independent of whoever, where player one is. But that's not true, because they will end the game. Damn it, it's so confusing. Okay, I'm gonna start making notes. All right. Expected points this game equals that. So expected length game equals it's going to be whatever the smaller of these numbers is. Equals min x, y, z. We'll divide by 2 because we say on average you move 2 spaces forwards. Let's just say that's the expected length. But of course, this can be a more complex function. Make it a float. X, Y, and Z are integers. What's the problem here? You're not allowed to do that. I think you are. Yeah, you are. We'll see if it runs. Okay, so this is the expected length of this game. Expected time remaining equals... So if our turn count is... So when exactly does it finish? It finishes... after 100 turns, so after turn 99, after the turn count is 99 is the last one. So it's going to be 100 or 99 minus self.turn count. Expected games remaining. So it's going to be time remaining, and these are all just averages and estimates divided by how long is a game? Like, we'll just average it. So, yeah, that's what the GPU looks like. Do we know roughly how long it'll be? We have to look in the code. Damn it. Early race end equals true. New hurdle race. So hurdle race. $30? Is it just fixed at 30 always? It is. Start stretch equals 3 plus... Oh, that's talking about where to place the hurdles, but the length is 30. So if we just do divided by 30... So total expected points equals expected points this game plus, let's say, 4/3, because that's expected number of points for a game, times expected games remaining. Expected length this game. But we're not accounting for what if the game won't end if it gets interrupted. Don't worry about that. To subtract this as well. Alright, that's a mess of guesses and approximations, but now let's have a look at the points. So it thinks throughout the whole 100 turns we'll get this many points. Okay, let's see how that changes over time. What the heck? We think we'll get 0 here. Oh, because it's game over. Now it's going down. Because we're not adding in the points we already have. Does it matter what the points we have? Yes, it does matter. Of course it matters, because that will determine our final product, which is the 4 games multiplied together. So I need to know what my current score is. Do I know my current score? Do we have to work that out? Oh, I recorded it here, but I didn't do anything with this, so... Okay. Just say... my scores is going to be a list of ints. And then return plus whatever my current score is for the 0 game. Alright, let's see what we get now. So you would expect roughly whatever it says at the beginning to be roughly whatever it is at the end. Like we think, okay, right now we think we're going to get 6.76 points over the entire game. And as time goes on... Why is it getting so big? Yeah, but the scores are not the... So the number of goals is going to be like 12. So 12 times 3 is like 36. And then you add in the silvers, which is 0. So the score should be like 36. How on earth does it get to that number there? Doesn't make any sense. Plus self, my score is 0. What is my... Let me see this. What kind of numbers are in there? What? Why are the numbers so big? 14 golds. Would be like 3 times 14. Why is it in like 14,000? Something is so wrong here. Golds? That's how many golds we get. That's how many silvers we get, and this is how many bronzes we get. We don't even bother counting them. My scores equals golds I times 3 plus silvers I for I in range. I don't understand this. Golds, silvers. Show me what these values are. Oh, you know what? I don't think they're giving us... What are they giving us? The number of medals? I thought it was just the raw number of medals. Oh. Score info containing a breakdown of each player's final score. Contains 13 integers. The first integer representing... This is so wrong. This is literally nowhere near what the input actually is. Oh my god. 1 line per player. Ordered by players. So for 1 player, first integer represents the player's current final score points. Thirteen integers. The first integer is the total score. Oh, okay. And then you got 3 integers per minigame. Alright, let me try and unpack this. Line 1, line 2, or should we just say score info 1, score info 2, score info 3. We want to find which my score info equals, we'll do this, 2, 3, player, yeah, because that gets my score info. Now, the first integer is the total score, but I don't want that right now. Okay. My hurdle Hello Razor. In game, when you hover over a nickname, you have a table with scores. This is literally the score info table. In game, when you hover over a nickname, yeah, I was unpacking it incorrectly, I guess. I thought... I don't even know where I got that guess from, but I thought it was 3 integers and 3 lines, 1 for golds, 1 for silvers, 1 for bronzes, but it's nothing like that. It's 1 line for player 1, 1 line for player 2, 1 player for player 3, and each line has, yeah, what you said, all that stuff, plus the total score, which is at the front. So if I want my hurdle golds, so I just want my score. Alright, we'll just, for now we just care about my hurdle score, so let's say it's gonna be my score info. So it's gonna be the second integer, if we want the golds for the hurdles, plus my score info 2. And then do that. My current hurdle score. So that's my current hurdle score. It's not even, there's no reason to even use this because it's only useful when we have all the scores. All right, well, we'll just do it for now. My hurdle score, all right. All right, let's try that then. So we're predicting for hurdles that we'll get 6.76 points overall throughout the entire game. And that's going up because we're getting golds, which was against our prediction. Our prediction was an average. We were assuming like somewhere between silver and gold every game. But because we're getting golds every game, our prediction is going up. That's correct. Because we're grabbing all the golds. And we get 14 golds. So the contribution score, why does it say 23 points? Oh, because it thinks this game that we're in right now is gonna finish before the cutoff, but it gets interrupted. So it's adding in an extra. No. Total expected points for my hurdle score. My hurdle score is 3 times the number of golds. So 42. So why does it think 22.7? Are you sure you are winning only hurdle races? I mean, I'd be very surprised if I'm winning other races, but maybe I am. What the heck? I'm winning skating races? 6 skating races? I'm not winning any diving races. Skating kind of makes sense, I guess. Because... well, they've won 6 each, so that's crazy. How am I winning 6 skating and I'm not even doing anything for the skating one? Archery, I got 1 gold. Wait, I've won all the skating races so far. How? Which one's skating? This one? But I'm not even trying that game. Okay, but yeah, you're right. So seven hurdle games, that'd be 21 plus the prediction for this game, which is getting cut off. So the code should be adjusted to account for that, but whatever. Okay, so the numbers all make sense. So this is a kind of a decent measure of expectation. I don't understand why we're winning the skating ones. That's weird. Not just a few, but all of them. Oh, but the skating one is continuous? Does it reset? When does a game reset? Does it never reset? So if you're ahead, then you'll just keep getting golds? It's just one continuous game. That just makes things way more complicated. Oh, no, it does reset. When does it end? I don't understand. You know what? I think that the gold boss is only focused on one strategy. So these bosses... These are the bosses... Wait, which bosses are these? Are these the bosses for... or maybe I'm still... Maybe these are still the bosses for wood? No. No, it should be bronze. Okay. But yeah, you might be right. Maybe they don't care about skating. It still doesn't make sense that I'm winning all the skating games, but fine. I'll take it. It seems like... All points for diving, no mistake. Oh my god. That's weird. Is that a good strategy? I think they're continuing to do that because they realize I'm not getting any points in diving. But they shouldn't care about me. They should care about the other boss as well. But they're neck and neck. They have exactly the same points, so they actually are not worried about the other boss. So I think it's because I've showed no interest in diving. They just keep diving. And they're getting silvers for the first game, so... I think the problem with this boss is that they have the same AI, so it's a really weird situation where they're getting joint silvers all the time, so I don't think this is helpful. I think we've got to stop using the boss. Just use someone else. I don't know, use these guys. This is a weird case where if you've got two people with the same AI, then you're not really playing against two people, you're playing against one person and he's getting double the points, sort of. It's really weird. Now let's just see. So what I'm expecting is that I'll probably win the hurdles games, but they let the other games. Interesting. So they are actually optimizing the hurdle games, or at least one guy is. Interesting. It's like this guy who is basically the top ranked person in this league seems to be doing the same thing I'm doing. But every now and then he's throwing some moves into the other games. Like on the game over screen. On the game over screen, he's actually probably doing moves on the other games to make it. But otherwise, he's optimizing the first game. Why though? That's not, you don't really want to do that, do you? But he won, so fine. I think it's because I'm also optimizing the first game. It's sort of, he's just trying to stay ahead of me, and he knows that he's winning in the other games too, so... But he's not worried about the third person. Oh man, I think that's as much as my brain can take for today. But I really like this scoring function now, so... So we've optimized one game, which we already did before, but this time it's using a probability function. Yay! So it's different. But the nice thing about this probability thing is it's completely uniform for the other 4 games. So if I can construct a probability function for the other 4 games, do you think you can test in Arena now? Oh yeah, I could, yeah. Yeah, go on then. But I'm probably going to get like 0 points. But then, yeah, it is just doing what I did before, so... No, but before there were 4 hurdles games. What was I doing? Oh, my strategy for beating wood was really just to always run 3 spaces. But when there's a hurdle in front of you, jump. But otherwise, always run for 3 spaces. So this strategy is optimizing the hurdle race, but it might actually... As long as I get a few silvers in the other games, which you may just get by chance, then I think this will actually not be terrible. No, it's not going to be enough to pass the league, but... So now when I throw in the other 3 games and balance it better, maybe I'll have a chance of getting to silver. Okay, let's see what happens then. Yeah, it's not that bad. Why does the music keep stopping? Stop it, YouTube. It thinks I'm not listening, so it pauses the video. Alright, I'm just waiting for this to stabilize and then I'll probably end the stream there. So offline I'm gonna have to just look over the maths again and maybe just try and come up with some probability thingy for these. Like they're all It's all just a case of you take at least this probability approach. The statistics that's involved is you find what the true distribution is for winning the game. And it's going to be something complicated like some binomial or some Poisson or whatever. And then you just approximate using the Gaussian, and then it becomes really simple because you just literally just call normal distribution for a given value. And it's that value which is the complicated bit, but you don't have to run any Monte Carlo simulations, you just call that. Normal distribution is just like a good way of approximating any centrally distributed distribution. What other strategies do you think might work? I think overall, like if I weren't doing this probability thing, I would just be doing some other measure of approximating how good I'm doing. So I think overall the general strategy should be, if you look at what happens if you press up, what happens if you press left, what happens if you press down, what happens if you press right, those 4 states, and just try to work out which one's the better of the 4. It's really just down to how good your function is for working which is better. And that could mean simulating several steps ahead, like making a tree of possible things that could happen, pruning the tree, like cutting off. So that could involve like, because my whole thing is based on random picks, like, but that's obviously not what people are doing. They're doing smart things, like they're probably going to jump over hurdles, things like that. So you could do some sort of simulation where you're simulating the next 10 steps, say, and people are doing more sensible moves, which will be the more of a simulation approach. But yeah, I can't think of anything wildly different to that. Clement from the CodinGame team, hello. I do really like the game so far. This was quite unique, I think. I mean, I know that you guys have had a 3-player game before. I think it was the cooking one, was it? The chef one? But that was like co-op or something like that. Or there may have been others. But yeah, I mean, you got 2 interesting factors here. One, that it's 3 people, and the other, that you're doing some sort of 4 games with 1 controller thing. Because I'm like I sometimes speedrun games, so I have seen people do this where they play like Pokemon on one game and don't know, like Mario on the other, and then pressing the same inputs for both games, which is a funny kind of speedrun. But so Code a la Mode was co-op, but we had another 1v1v1. I can't remember which one that was. I probably took part. I've been taking part in all the major ones since Hyperloop, or whatever it was called, the Bomberman ones. That's probably a decade ago now. But yeah, I'm enjoying it, and I have been recommending this site to all my viewers whenever they stop by, so my current strategy, I've just basically done a sort of, I've completely focused on the hurdle game right now, and next streams are going to throw in some stuff for the other games, but I've sort of used a Gaussian distribution to roughly approximate the probability that I would win this game if everyone was doing random walks. And that comes down basically to this formula, if my maths is correct. And so I just sort of plug that in and say, and of course this is overkill for this game because we already know what the optimal solution is for this game, so for hurdle. So it doesn't change anything, but the idea is it's kind of a sort of uniform measure of goodness between 0 and 1, which would be uniform between the 4 games, even though they're wildly different games. So my idea is that I'll do this kind of approach for each of the 4 games, and then I'll have a rough estimate of how likely it is I'll win each game. And from that point, I'll be able to say, okay, pressing up will increase my likelihood for this game a bit, but it will wildly decrease my probability for this game, so let's not press up. I don't know, that kind of thought process, but it would mostly be based on what I predict my final point score to be, based on each of the 4 key presses and these individual probability distributions. I don't know, I'm going to have to do all the maths offline, because this is all stuff that I did back in secondary school. Alright, I'm waiting for this to stabilize. This is a surprisingly high rank, given that I have literally just focused on this one game. And it's still going, so if I promote, that would be really weird, because I've not done anything about the other games. I don't think I will promote. The problem is when you face the boss, and I guess this is unavoidable because the boss is like deterministic, but it's not exactly a fair representation of what it would be like when you face other people, because the 2 bosses have identical AI. So it's almost like you're versing a boss with double stats, sort of, rather than 2 individual people with their own desire to win. Will you stream again tomorrow? Yeah, I'll try to. Hang on, I need to check when. So a streamer that I follow is doing a game jam, and that might be starting tomorrow as well, or the day after. If that starts tomorrow, then I'll be doing that instead, but where is his Discord? Captain Coders Academy. Game jam. I've never done a game jam before, so that is a thing I'll do, probably. I don't know. I think he's doing it in like 2 days' time. So yeah, I probably will. Even if that game jam happens, I'll probably throw in at least maybe an hour tomorrow, to try and put up one other game at the very least. All right, is it stabilized? It has. Well, that's a surprisingly high rank, but that's not actually that surprising, because I imagine a lot of people are still using their code from Beating Wood, which was still tuned to the hurdle race. So maybe a lot of people are still fiddling, and the ones who have adjusted their code properly have probably already, many of them have probably already promoted. Let me check the leaderboard as well. So Ku is 855. Wait, what? 855? Oh, there's a lot of people in silver. Ku is in silver, and that's 855. Wait, and these guys are... How many people in silver? It's like over 1,300. Oh, that's quite a lot. Okay, fine. So my guess is it's not that hard to qualify from bronze in this particular game, because it seems like there are a lot of people in silver. 1652 in silver. Okay, interesting. So it seems like think it was, who said that? It was you that said that, Razor, isn't it? That the boss is kind of quite single-minded, which means they're probably easy to beat. So yeah, soon. Yeah, I'm guessing the next live tournament like this will be the winter one. It's usually like that. And last year that came up at the same time as Advent of Code, because that is a thing that runs in December. So I was struggling to juggle both of them. And I also taught CodinGame in Saudi Arabia in January, because I was basically teaching AI as part of a workshop, and I used CodinGame as the basis for it, because I was like, okay, I'll give them something to try and program and compete on. So yeah, basically I had a whole class of students using CodinGame for that. That was fun. We were doing the Bomberman game, specifically. Hyperloop, I think it was called. Oh, rank 4. Alright, well, it's possible that I might just randomly promote over the next 24 hours, but I think... Is anyone else? I swear I'm the only one who's ever in this list whenever I'm on. Maybe I'm just streaming at a weird time for the rest of the world. So there's no one... If I were to raid, I would have raided someone who's doing CodinGame, so I guess I'll just stop there. Alright. Thanks for watching, and I will try to put in a little bit of this every day, but if this game jam is coming up, I'll be juggling both, but we'll see. Alright, thanks everyone. See you next time. Bye-bye.